So guys, you can see that this is our PIC16F877A USB to TTL device to send and receive data. This over here is a PIC16F877A. Now let me show you the UART terminal. What I do is that I send some letters, like I send 224 here, 224. What happened is that it makes it 324, adds 100 to it. I send 4, 5 or 5, 6, 7. Now it becomes 667. It had added 100 to it. Now I send 7, 18. It will add 100 to it and send it back. So what is happening here is that whatever we are sending the string to the PIC is simply adding 100 to it and then again converting it back to the string and then sending it over here in the receive terminal. So let me show you the code. What is happening here? What is happening here is that we initialize the USB to TTL device, then we took some variable, a char, integer which will store the converted value, and then again the result 1 because it will be again converted to a string to send it back to the terminal. So what we do is that we receive the data coming from the user with a delimiter /r. Then we convert this data into a string and store it in this result, and then we add 100 to this result, and then we again convert it back to a string to be sent over to the UART terminal, and this is again sent back with added 100. So that's it, guys. Hello guys, welcome to learning microcontrollers. In this video I will show you how we can use a PIC16F877A microcontroller or any other PIC microcontroller using micro C for PIC programming to convert user entered text or strings, or user entered text or strings sent using the UART channel or from any other source that you are getting a text or a string. Usually UART serial data is in the form of text or string ASCII standard. Then like you get a number of 350 and you want to do some processing. You are getting 350 reading from the UART terminal, but now you want to do some processing on it. You want to multiply it, divide it, or apply a condition like either it is greater than or less than something. Then you need to convert it into an integer in an integral form. So for that purpose you need a technique in the C language using an ATOI command. So this tutorial is about that how you can convert a text or string, a user entered text or string, into an integer for processing purpose. So we can apply both arithmetic and logical operations on it. So let's get started. So guys, for the purpose of demonstration, I'm going to use this CH340 USB to TTL device. You can use any available USB to TTL device at your place. It can be FT232 or CP2012, whichever is available. And this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. You can use any PIC as well, supported by the micro C. So guys, now what's going to happen is that I will connect this device with a PIC, and then what I will do is that for displaying the output I will be using the computer. So the data will be sent to the computer and data we will enter also from the computer. You can use the buttons as well or any other interface, like you can input the data from SC05 or mobile through the Bluetooth and receive the data back to SC05. That's up to you. So I'm going to use a USB to TTL device. It's easily available. So what I'm going to do is that I will program the PIC in such a way that first we will enter a data from the computer to the PIC. So what it will do is that a PIC will receive the data, and then that will be a number, and then we will apply the conversion command, and then it will convert that number into an integer. Then we will apply an arithmetic and then a logical operation on it, and then we will reconvert it into a string and send it back to the computer using the PIC. So in this way it will be verified that we can do this using PIC using some special commands. So let me show you how to connect this USB to TTL device with a PIC microcontroller. So first let me label the device, although it is already labeled. The topmost pin is the 5 volt, then VCC 3.3 volt, TX, RX and ground. Now 3 pins TX, RX and ground are in every USB to TTL device whichever you take. While for the power pins there might be VCC in every device, but in few devices there is not 3.3 or 5 volt pin available, so it doesn't matter. All you need are these 3 pins TX, RX and ground. They are available in every USB to TTL device. So guys, let's connect it. Connect the ground pin directly with the ground of the PIC. For the TX pin, connect it to the RX pin of the PIC, that is pin number C7 or pin number 26, and for the RX pin you will connect it to the TX pin of the PIC, that is pin number C6 or pin number 25 of the PIC. In this way TX of the PIC goes to RX of the CH340 and RX of the PIC goes to the TX of the CH340. Now for the power pin, you do not need to connect the power pin with the PIC, because in my case PIC will be powered up by the PIC at 3, and the USB to TTL device will automatically get powered up by the computer. Once you connect it to the computer, computer will automatically power up this device. That's all. So guys, this is it for the connections. Let me introduce you to the hardware before we move on to the programming. So guys, this over here is our USB to TTL device. You can see that only 3 pins are connected as shown in the presentation, and you can see the LED is on, although the PIC3 is not powering up the circuit right now, because computer is automatically powering up this device. It is connected to the computer using this USB extension cable, as you can see. So guys, this is how the USB to TTL device is going to power up, and this over here is the PIC16F877A, and that is the PIC 3.5, which will power up this circuit and also for the programming purpose. Rest is just a trainer board. So this is the very simple setup. So let's get to the micro C for PIC programming now. So guys, this is our micro C for PIC. Let me zoom in so you guys can see better. It's version 7.6.0, and if latest version is available, just use that. Latest is always better. Click on File, New Project, like this. Then guys, this window pops up, New Project Wizard. Click on Next, write the name of the project, and the name of the project is, you can write anything that you prefer. I write here text to integer user entered UART tutorial by learning microcontrollers. So that's the name I wrote, and select the path where your hex files will be created. Select the microcontroller you are going to use. I'm going to use the PIC16F877A, and the crystal connected to the pin number 13 and 14 of the PIC16F877 is 20 megahertz. Click on Next and Finish. Now guys, this page pops up. Press Ctrl S to save your work before you do anything else. The work is saved now. Now guys, first of all, go to the right and select the libraries you are going to use. So first of all, I'm going to use the std library. Here is the ATOI command. This is used to convert the text to integers. And then guys, we will need the UART command, UART library for connecting the USB to TTL device, like this. And then guys, we cannot send integers directly to the device or directly to the UART terminal. We have to convert those integers into strings again. So for that, we will also need the conversion library as well. Now guys, before we do anything else, first of all, what I do is that I initialize the USB to TTL device, the UART library. So click on this UART1 init command. This will initialize the UART module of your PIC. Just copy this command in the example here, go back, place it in the one-time loop like this. Now guys, this is the baud rate. You can set any baud rate, but once you open the UART terminal, remember you have to write this baud rate. And then guys, give the initialization delay. Any delay will be preferred. I prefer 100 millisecond delay. But remember that giving this initialization delay is not necessary in the newer version of micro C. The older versions that I used to use, like 4.8, 5.2, they needed these delays, because usually there was a problem that when the processing speed is good enough, it used to ignore commands. So in newer version, it is not an issue anymore. So it's not necessary, but I have an habit. Now guys, the UART module is initialized. We can move on to the forever loop. So in the forever loop, I write while 1. Forever loop starts here, ends here. Now guys, in the forever loop, first of all, we will need to convert. Okay, there is a command ATOI. This command, I double click on this. Now see this command, what it says is that long ATOL, not ATOL is long, and this is the ATOI command. Function converts the input string into an integer value and returns the value. Now that's what we need. We need to convert a string to integer. So just copy this command from the example here, paste it in the one-time loop like this. Now guys, this is an integer that whatever the integer is placed here will be converted, but we don't need this integer. We need an integer that is sent by the user. So for that purpose, go to above the void main and initialize an integer, or you can simply initialize a char. Just write down random number, and it should be an an array of char. An array of char having 8, 0 to 8 means 9 characters is a string. So it's a string having 9 characters. An array of char is basically a string. So we write this here, that whatever is in the number, it will convert it into this, and this will be an integer. So initialize it, just make it int result. Now this is the integer, and this is the char. So whatever the string is in this stored in this variable will be converted into an integer and will be stored here. Now first of all we will need to receive this data from the user. For that purpose, go to the right into the UART library, and inside the UART library you have this command UART1 read text. So we will read the data from the user. Here you have these three commands, just copy them, paste it here like this. Also bring this. Now what is the character we are receiving from the user? This is the character. So this is what we are going to get from the user. So I make it here. Now this is how this command works. Let me explain them to you. Now first of all, I delete this and copy and pasted it here. Now guys, what is going to happen is that this command, if UART data ready, it checks if the receiver buffer is ready to receive the data. If it is ready to receive the data, if you don't use this command, this loop, still your program will work, but it will keep on receiving no value. The data is not sent, it will keep on showing you a blank space, like blank space is moving. So if you use this command, the great thing is you don't have to get the blank spaces. It will only allow this loop to be executed if the data is there at the read buffer of the UART protocol. Now guys, this command UART1 read text is a syntax, and inside it this is the variable which will store the data coming from the user in the form of text or a string, and this is a delimiter. Now we define our delimiter as /r. Whatever the number we send must end with a /r, only then it will consider that this is the number it have to receive. If you don't use a delimiter, then there is a problem that some random number may enter due to noise. So if you use a delimiter, it will allow you to send a special character like a full stop or whatever you prefer. If that full stop is there, only then it will consider the letters to be left to be considered as string to be read. And these are the attempt, just 10, it's fine. Now guys, whatever the data is received, number is received, it is converted using the atoi command into an integer and stored in this variable. And now guys, we do not want to send this directly back to the terminal. This will send the data back to be displayed on the screen. It is a write text command. We delete it right now, we don't need it. So what we do is that now we perform arithmetic operations. I write whatever the data is received, now it is converted into an integer in the form of result equals to result plus 100. Now whatever the data is received, 100 will be added into that data, and then once the 100 is added, then now we will send it back to the screen to display it again. It will show that whatever the number we sent has been converted into an integer, and then we have performed an arithmetic operation on it. We have added 100, and then again we have displayed it back on the screen. So whatever we enter, a new value having 100 added to it will come back on the screen on the UART terminal. Now the problem is we cannot display result, this integer, directly back on the UART terminal. We again need to convert it into a string. Now to again convert it into a string, we will need to convert this integer to a string again. Now go to the right, we initialize a conversion library, expand this. Here you have this command int2 string, double click on it, this pops up. Now we will again convert the change value or process value back to string to display on the UART terminal. Now this command int2 string, place here whatever the integer is. Now we will need another variable which will store the converted value of this integer into a string here. So we initialize another variable char result, just give it 20 characters maximum. So this will be result 1, so they don't get confused. So this result 1 is a array of string which will store the converted value of this integer into a string. So that's what is going to happen here. So this is the command int2 string. Whatever the integer is here stored in this variable will be converted into a string and will be stored in this string variable. Now we can display this on the UART terminal. Now go back to the UART library and look for the UART write text command. This command, double click on it. This command over here, UART1 write text, copy it, paste it here. And now what we want to write, we want to write this result 1. Now if I directly try to send the integer value to this value here, it will not be able to send, because we cannot send strings integers directly. So we need to convert the integer to a string. Now we can display this string on the UART terminal. Now that's how this works. So now what we do is that we simply now build this code to see if there is any error. Check for errors, no errors. Okay, now we burn it into the microcontroller, open the PIC16 programmer tool, select the microcontroller. PIC16F877A is the one we are using here. Go to the file, import hex file, and this is the file we just created. Click on write. Okay, the new file is being written. Just wait for the file to be written. Let me zoom out. Okay, it is writing the file. Okay, the program is written. Okay, let me connect the hardware. Okay, let's power up the circuit using this PIC16 programmer tool. Let me connect the device. It's connected. Now go to the UART terminal. Let me zoom in further. Okay, the COM port to my USB to TTL device is COM4. You get this COM once you connect the device in the device manager and click on connect. Okay, now we have to send a number. I send like 12 /R, that is the delimiter. Send. Okay, this is the first value. So 112, this is fine. The first value is basically 0, so it's no issue. Happens sometimes. Okay, now again I send some other number. I send 24 /R. See, it becomes 124 because we are adding 100 to it. Now I send 112. Okay, 112 is sent. It becomes 212. See, it is added by 100 and sent back. Now I send 334. 434. See, it added by 100. So what is happening here is that this string goes to the PIC and PIC simply gets the string, then it converts it into an integer, and then it adds 100 to it. Then again it converts it back to the integer and sends it onto the UART terminal to be displayed here. So that is what is happening here. We are basically converting user entered strings into integer and then performing arithmetics on it and then sending it back. Now see, 555, it becomes 655. Now I make it 785. Now it becomes 885. Simple as that. So guys, this is it. If you guys have any questions, you can ask me in the comment. I hope you guys learned something from this video. Thank you very much for your time and have a nice day.